I don't know if that'd be screen resolution or. There's a zoom tool or something.
That helps a lot.
Okay, that's better.
That's better?
Thank you.
That sounds familiar.
Simple stuff.
Okay, and I'll post that in the other hangout.
I don't really know how to make does anybody know how to make the file toolbar stuff go away in Jupyter? Or can I?
Yeah, I think it's under view, and then just do it to get it there. So you got toggle tire.
I'm gonna leave the toolbar, because there's no telling. I may forget how to get that. Yes.
So before I was a pilot, so anything we like we can like pull out of it, we have like file on the one second.
Hopefully pick you up.
Yeah, I can talk pretty loud. All right, so why don't we go ahead and get this party started? Are you gonna bring a chair?
I'll come up here.
Do you want to hang out?
All right, so we're going to go over the examples you have to read today, and these are pretty much, I took them right out of the book. These are so much, there's something called iris, iris the flower, that some of you have seen. Apparently, people took data measuring iris, petal size, petal width, petal length, three different varieties of irises, and you can use that data to show. I believe it was somebody on. Might have been Cat that I got the notebook from, but I can share it as well. But before we get started talking, I more or less we got mentioned to a few people last time because I waited till the very end and people left. So the next chapter 4 is linear algebra. And yeah.
They're saying there's a lot of echo and they're straining to hear.
Oh, that's a big room. I don't think that's. Is your volume on?
I'm actually don't even have the screen up. I'm just listening to. I'm trying to get people off the whole page.
Okay. Well, so if anybody here is on the Google Hangout, they could just, roll the volume down or mute their volume. So next time we're gonna talk about linear algebra. Now, the chapter is somewhat misnamed, and it really talks about vectors and matrices, and really not a lot in a linear algebra sense about vectors and matrices. And the majority of the chapter is creating your own vector class. from scratch. Now, for Python programmers, that's probably going to be not very interesting, other than the whole mathiness of it. You might find somewhat interesting. However, the creating a class might kind of bore you a bit, but it might just be a good exercise for you to do to refresh your memory if that's what needs to happen. For the rest of us, for somebody like me, I plan on going through it because I'm familiar with Java, with C++, and class creation, and that sort of thing, and in those languages, but never done it in Python, so I'd just like to see some of the details of that. My guess is we're going to be using those, since it's from scratch, since the book is out from scratch, we're going to be using that class later in the book. I really hope that's not the case, but I don't see why it wouldn't be, because Python out of the box gives you a lot of linear algebra capability, and I'm not sure knowing how to add, subtract, multiply, and or divide vectors and matrices is going to be altogether useful for what we need to do here. Certainly in the data storage and data retrieval sense, right? Vectors and matrices are a good thing to know about, but linear algebra might be one step too far. But we'll see. All right, so yeah. Well, so in something like distance is generally used, like for say for linear regression, which we'll do if we have time and end up going through multiple regression. Then you'll use a distance formula. If the objects you're trying to calculate the distance between is a pair of vectors, then that would be useful. Then calculating the distance between vectors would obviously be useful in that regard. However, I'd have to see the data. I don't know what he intends to store as a vector. And vectors have very specific mathematical properties. If you're going to start throwing the word vector around, like you can have I have a vector, so I have a barrel of oranges and a barrel of apples, and I'll call that barrel of oranges the X component, and I'll call this barrel of apples the Y component. Well, they'll add. You can add barrels of oranges to barrels of oranges, and barrels of apples to barrels of apples, but you can't really multiply the two vectors in the mathematical sense. So it doesn't make. So if you're labeling data items and calling that a vector, there's a restricted set of mathematical operations that you can use. K-nearest neighbor is one of the algorithms later in the book, and you sort of cluster data items together into sort of bunches, and you look at K-nearest neighbor sort of graphically. So it might be in that sense that we'll be able to use an honest to goodness vector and a vector distance to say, well, this attribute or this set of attributes all seem to be clustered together, so they may be important in relation to each other. Whereas these set over here are important within themselves, but the two groups might not be related. In that sense, you can kind of come up with you can sort of invent the idea of some sort of minimum distance between a set of parameters and say, well, I know this is a class 1, say, and that's a class 2, but I know that they shouldn't be related. Did that make any sense? I mean, that was a whole lot of math stuff.
I think some of this was chapters taking effect, it'll make sense later.
Just hit the I believe button. Yeah. You bet. I'll take that. Okay. All right. So, we'll get started with chapter 3. This is, mean, it's sort of boring. Who here has worked through the examples in chapter 3? Okay, so we have a few. Now, I just, and I'm going to get in the practice of doing this, but I just shared the notebook that I created on the Meetup site. So if you're online and you're on the Meetup site, you can go get the file. And if you have IPython installed, and you'll be able to open up the the notebook and follow along without having to read the screen if you don't want to. Right, so what we're going to use quite a bit, and in fact I use on a daily basis for to do plots for what I'm researching, is Matplotlib. Now, apparently there are other plotting packages that you can use, some of which cost money, some of which are free. And I think at the end of the chapter he mentions ggplot, which is part of the R programming language, but there is a port of ggplot for Python. And it sounds, his words are, the author's words are, it's a publication quality plots. All my physics buddies use Matplotlib, and that's what they jam into their publication. So I feel comfortable saying this is also a publication quality plotting capability. I guess you can make prettier plots. Maybe ggplot gives you more control over the axes and hash marks and the like. And might do a better job labeling, but it sounded like it was, and again, in the author's words, it's not intuitive. It doesn't have an intuitive interface. And quite frankly, if you do a lot of visualizations, I'm not really sure anything's intuitive. How you specify axes and that sort of thing, yeah, everybody does it different. Everybody's got their own way of doing it. So this isn't anything like I've seen any other language do it. But like I said, once you get used to the logic of Matplotlib, everything works the same way. So you can almost say, well, so I said, make my y-axis this and this other type of plot. What if I type that in here? And you got a pretty fair chance that it's going to work. So now this is a right. So what I've done here is from Matplotlib import pyplot, and then I aliased it. Right. We've all seen, for those of us who aren't programmers, we've seen this last time, and then I added this. I think somebody. So I'm not too familiar with what magic. Is that what?
It's a magic command.
It's a magic command. And what the %matplotlib inline forces Matplotlib to do is to print my plots on the or inside the notebook. If I didn't do that, I would get whatever image tool the operating system recognizes as the default image tool. The images would pop up in that tool. You may want that, you may not. But this is so this is just a simple line plot, and it's just gross domestic product versus time over time, right? So here I've got a list of years. Here I've got a list of GDP, and then you'll see I use my alias plot, and then my x-axis, my y-axis, what color marker styles to use. So I get the dots for the points, and add a line and make it a solid line, and then obviously add a title, put a Y label on, and show the plot. So this is after I execute this. So that the one thing you should always have, and I'll try to, you know, if I see it, I'll try to remind you. And I didn't do it here, right? The bottom axis seems, you know, sort of self-evident, right? I mean, 1950, 1960, those, why wouldn't those be years? You should always have labels, right? You should always label your axes. And if there are units, like meters, like time, like there should also be on your axis somewhere a label for your units, right? So that should be years, right? So that you don't, if somebody picks this up looking at it in a publication, right, they'll be able to at least tell, all right, so the years, I'm plotting GDP in billions of dollars, right? So this is, like, the 2000 is, can anybody tell me what that number would be? Well, so, so the hash mark, right? What does it's 2000 of what? Right, it's $2 billion. Now, I wouldn't have done it that way, but he's done it that way. Because I would read that as $2,000 billion. And I would call that 2 trillion, but maybe it's a typo in the book. I don't know. But again, right, make sure you've got labels on everything. Make sure titles, units. The next type of chart, bar charts. And bar charts are really good for showing, he says, for showing a single variable, how a single variable changes with respect to a discrete set of items. So the easiest way to explain that is showing the example, right? So again, right, I've got a list of movies, and then the corresponding number of Oscars for each of the movies. I suppose some of our Python programmers might have made that a dictionary and plotted just as easily, but now let's see, bars, 0.8. Okay, so this is and so what I've done here, right, with the list is I want to make sure I can get all the boxes in my plot, right? So I want to give the boxes a particular width, and I just use a list here, and I run over the list of movies so I get the right distances between the boxes, right? So this is not something, this line is not necessary. However, I'll show you what happens if you get rid of it. And then, but before I do that, let's run through the commands real quick. Right, so plot dot bar, you notice this time we want a bar chart. Last time we just want a plot, a line plot. So we use plot dot plot. This time plot dot bar, and numbers of bars and the number of Oscars. And again, right, I label my y-axis. I didn't label the x-axis. And I gave the plot a title. And again, here we're adding ticks, so you'll see the ticks for each of the movies, and then the show command. So when I do that, right, nothing out of the ordinary happens. Now, if I get rid of can we see what happened? Let me try this. Oh, you know what? That's probably, yeah, for X ticks, yeah. Right. So nothing happened. So no, I can't get rid of it there.
Can you run it with plot bar movies by the number of Oscars?
Yeah, let's try that.
Nope, it doesn't lock.
It blows up if I do that. All right. Well, so when I did do it incorrectly, I got bars with no white space between them, and it made it rather difficult to read. So I probably should have left the bad example, but I did not. The other thing that bar charts are used for, which we will use quite heavily, right, are histograms. And histograms are useful. I don't know why. Maybe somebody who knows some Latin can tell me why they're called histograms. But because histogram kind of makes me think of history, and that's not what this is. It's a frequency. A histogram gives you the number of times a certain thing has occurred, right? So, ooh, I got a name there. What happened?
From collections import counter. You need to add that at the top.
Yeah. Oh, man.
Lowercase c.
Is it? Is counter uppercase?
Counter is uppercase.
I had it backwards. All right, so for this histogram, we're keeping track of some grades for a class. And again, the grades are kept here in the list. Now the decile is what the author's trying to do here is keep track of grades in a certain range, right, in a certain 10 grade range. So, right, what you see plotted below, right, are 0 to 10, 10 to 20, 20 to 30. So that's what this decile function will do for you. Yeah, it's kind of tough to. It was tough to sort of decipher, and so it took a little bit of thinking and work through it, right? And then again, right, plot the bar chart. So what he's offset the bars by 4, and then he's designated the axis here in plot.axis, so that so the first 2 are the x and the second 2 are the y. I don't know why they aren't in parentheses, but it's a plot axis. It's just called a plot axis.
Go back to the plot.bar. He's got a width of 8, so by 4 he's putting it by half. So the -4 works because he's a width of 8.
Right.
Most of type together.
Right. And then, right, plot your tick marks, your X label, your Y label, the title, and then the call to show to show the plot. Now, one thing that we've just gone through, what, 3 examples? 3 examples? And you've probably already noticed that most of plotting has to do with making the plot pretty, right? Putting the plot in some sort of visually appealing format. And it's not just for other readers or people who might see your plot. It's going to be helpful. Shouldn't spend, if it's going to take you 30 minutes to pretty up a plot, then it's probably a waste of your time if you're the only person who's going to see it. But you should go to the trouble of making sure that you plot something that you understand, that when you look at it, it makes sense. You might have to explain it to somebody else for it to make sense to them. However, the first person that should understand it is the person plotting it. So make sure you understand or do what you need to do in a span of, say, 5 or 10 minutes or so to produce a plot, produce a graph that makes sense to you. And again, he's gone through the examples in the book. He's gone through plots that we will probably use pretty heavily. Again, the bar chart, the histogram, we're going to make heavy use of. The line plot we'll make pretty heavy use of. Does anybody have a question? Yeah.
If you wanted to plot in two grades in the same plot, you just do the plot bar again with a new data set.
You know, I haven't gotten to that yet, but I think there's an image show. I think if you put plots together into another container, you can plot them one on top of the other. Do any of our Python programmers know the answer to that question?
Now, do you have an example of the lines down there? Put it on in the chat.
Oh, okay.
Okay, yeah.
Yeah, multiple.
I did do it ahead of time, so I know they have the example of the 3 like line plots, whatever.
Right.
But I was wondering for how that would work with the bar chart, you don't want all your bars on top of each other.
Yeah.
I know you can do it with ggplot. I've worked with that quite heavily in R, and it's easy in that. It should be quite easy in here too.
Right.
Probably what you do is you would set your bar width, and so in this case the bar width is 8. So you drop it down to bar width of 4. You'd offset 1 to the left, 1 to the right. So instead of doing the plot.bar x minus 4, it might be x minus 6 on one, and then x plus 2 to get them to spread from the center a little bit. And then you'd give the second one a separate color, and then you'd plot it.
Yes.
Do you more commonly use it with scatter plots where you overlay one scatter plot on
I'm sorry, say the first part of that again?
with the overlaying of plots?
Right.
Do you more commonly use it for scatter plots?
I have used it for scatter plots. When I've also used quiver plots on top of contour plots or on top of density plots, so that you can see, you know, sources and sinks and, you know, flow direction. But again, that's I did that a while ago, and it's not coming to me how it was I accomplished it. I'd have to open up that notebook and have to look. I know there's a way to do it. I'm just not entirely sure what that would. But image dot plot dot image show comes to mind, or figure dot image show comes to mind. Yeah.
You asked about the etymology of histogram.
Mm-hmm.
Very quickly, Wikipedia says the correct derivation from ancient Greek, histos, anything standing upright, gram, and drawing for reference.
There you go. So it makes no sense whatsoever. Histogram is based on the Greek for Greek, Latin,
That's ancient Greek.
ancient Greek. So histo means something standing up, like the bars, and then the gram for graph.
I was just thinking of probably how much usable dimensional nature of list for array. Do that kind of graph. Because you have
Multiple, yeah, that sounds like it will work. But like I say, right, it depends a lot on, you know, who's going to plot. If it's just for you, like I say, right, make it pretty enough that you understand what it is. If you've got to show it to a bunch of people, then you might, you know, want to make it as nice as you possibly can.
I was looking at the one website that I published in DC Viz Group.
Yeah.
They had a lessons learned after they finished their competition.
Right.
One was to make sure that they separated the data from the graphs, so that the graphs, data could change, the graphs could remain. I didn't
Oh.
keep those separate.
Oh.
So isolated. More stuff we're doing so small, it doesn't matter, but if there was more, the data required more manipulation.
Right.
It'd be nice if the graphs could be kind of dumb about it, they're just taking an X in a
Right.
wide array, and they don't care how that data is generated, so it's isolated, that's good.
Right. I know I have to spend a lot of effort making sure that that I have the right bounds for the data, so that I don't have to. I spend a lot, like an hour or two up front making sure that's okay, so that I can just I can take data and jam it into and I just get the view. I don't have to.
The Matplotlib, you're worried, you have to worry more about your access, that information on the access. You
Right.
need that information. Some of these other tools, especially computers, and I was trying to Plotly, it didn't care. I didn't have to worry about, spent a lot of time
Right.
in this code manipulating
Maneuvering.
the data just
Right.
to get on the axis.
Right.
Where if you had tools, which these guys did,
Yeah.
it didn't care about it, then it could just take the data, it would worry about
Yeah.
it, it would handle the access.
It pretty it up for you,
Yeah.
or make sure you were getting the view that you expected. Yeah. Yeah. Right. Right. Yeah. Most everybody I know hates making plots because it can be incredibly time consuming. But again, right, if what you're worried about is a publication quality plot, then you don't really have, unless you go right by. I think Plotly costs money, right?
No, actually, I did this whole thing in Plotly.
Okay.
I
Oh, nice.
posted the
Oh, okay.
notebook. But what was you can do it offline now, so it can be separate, and
Okay.
just like you
Oh,
have
okay.
this. But you can also get an account, a free account, as long as your data is small,
Right.
then it'll publish it to your
Okay.
account, and then you can share that.
Okay. All right.
So it's free,
Great.
but unless you have a huge amount of data,
Right.
and you want to use their server, then.
Then they're going to start charging. Yeah, sure. Yep.
Rather than hard coding a lot of the information which you're doing to this example to
Yeah.
understand, can you do function calls, parameters inside of it? So if I wanted to, want to know the length of something, rather than having to actually figure it out, I just would call in.
Oh yeah, sure.
Okay. That's
Yeah.
it.
Yeah,
An example gave this, so I didn't know if you could.
Right. And in fact, I've been using pandas for it's a function. I used a lot of Excel in a previous life. And pandas is great because it's just like Excel except it works. So I get to use all of the all that kind of thinking, but I get the plots that I want. And I don't feed lists, right? I feed a file to or parts of framer, rather than creating a list of values. All right. And this speaks a little bit to be careful what you're plotting. Make sure you understand what you're plotting. In this example, so on the y-axis, he's got a plot of the number of times he's heard somebody say the phrase data science, right? We have the year 2013 on the left and 14 on the right. So in this case, right, it looks like there's a huge increase from 2013 to 2014 in the number of times he's heard somebody say the phrase data science. Well, and he goes on to mention, right, that it's common practice to start your bar charts from 0. So if you notice in the top plot, he started almost 500. And then the bottom plot here, when you start at 0, you see that there is a bit of a difference, but, well, not a significant difference. Not very much difference. So, again, this is sort of a caveat emptor, right? I mean, because you really have to be careful about what it is you're plotting, even for yourselves, right? I mean, understanding of the data and the bounds of the data and the purpose behind the plot. Because it's really easy to mislead yourself. All right, and then now the difference between this example and the very first example, right, was the marker command. In this plot, he's not using the marker command, so there's no you don't see a dot for the data point. But this is it's also an example of plotting with 3 lines on a single plot, right? And in this case, right, you just make multiple calls to plot, and Matplotlib just writes the next plot onto the plot. And apparently in this, well, so he's called legend, and I think can I do this? Nope. Still nope. Oh, no, I'm fine, thank you. Right, so location does what you think it does, just maybe not in an obvious way. I don't know why 9 is top center, but one really nice thing about Python and the libraries are there is an enormous amount of documentation. So if something's not acting in an obvious way, you can take a look at the documentation. And the documentation is usually pretty good and pretty straightforward. And I don't know if anybody's looked at the Matplotlib doc, but there are also examples. So, I mean, 9 times out of 10, right, you don't want to reinvent the wheel. You can just rip a plot right off of the examples and then make the necessary changes. At least with when you do it that way, right, you at least know that you started with something that will plot. So if once you've imported and done what you made the changes you want to make, if it doesn't plot, you know that you did that, and not somebody else did. So you've always got that going for you. Any questions? All right. It's also a good practice, especially when you're plotting multiple lines, multiple sets of data on a single plot, that you differentiate those, right? So you have the dots for the blue dots for total error, the red dot dash for square the bias squared, and the variance, the green line. Again, right? You're using a plot to convey information in as quick a way as you possibly can. Yes.
So if I'm and I want to start analyzing data, just given the stuff, the first thing I'm going to do is go in and graph it.
Well, so that depends. If there are obvious relationships between your data, between, say, the columns of your data, then a graph might be a good thing to throw up really fast to show that relationship, and then you get a plot, and you can say, okay, that's what I expected, or I didn't expect that. Did I plot something incorrectly, or is that really what the data is? If, on the other hand, so as an example of that, right? Like the data I have, it has mass and velocity and some other stuff. So I can figure out energy by squaring the velocity, multiplying that by the mass column, and then dividing by 2, and there's my kinetic energy. Then I can plot that right against my time, and if it looks like I think it's supposed to, then I can say, yeah, my simulation did what I thought it was going to do, or I'm at least getting reasonable things out of the simulation. But if you've got number of times people have visited a particular site on a particular page in Amazon, and number of winter coats sold, and it might not be quite as obvious what it is you're trying to plot, against one column against another. So what you might end up doing, right, is first developing some sort of a hypothesis, right, and then you might then go, my guess is winter coats. One second, I'm sorry about that.
So let's just say the hypothesis is a direct relationship between month and the number of codes, the number of visits per site.
Right.
And then we would basically graph that out to see how linearly they all correspond.
Well, in that case, you're probably going to use a bar chart, right? A histogram, right? You'll number of occurrences of coat sales over months, right? Then you'll be able to bin the and you might want to get fancy, winter coats or light coats or whatever, and number of sales by month, sales of coat by month, right?
That's just two-dimensional. So if you
Right.
want to add a third dimension in a particular slide,
Right.
graph it in, how would you do?
You could color the bars. Right, you can make color mean something. So all the greens would be Amazon, all the reds would be, I don't know, some other site that sells coats, Macy's. I don't know, but it really, again, you can graph any one item against any other item, and then the question becomes, does it make any sense? And again, right, in science and engineering and math, and right, there are sort of these obvious relationships that you can, right, you don't have to necessarily develop any sort of hypothesis. You can just plot one thing against another or a set of things. And in fact, that's why I use a quiver plot and a density plot, is because I'm plotting in what you would call 6 dimensions, right? You can't really, I mean, the plots make sense to me, but I have to expend a heck of a lot of effort when I'm talking to, my advisor or, a colleague, and say, well, so look, that's, so that's momentum. I get that, but then why is it that color? And so, yeah, again, it's plot.
Tool that supports 3D graphs.
And there are tools for 3D graphs, but again, you have to be really. One nice thing about a plot is you can show it to somebody and they can immediately assign some meaning to it. Here's a bad thing about that: they get to assign the meaning to it, right? And then there's this whole, maybe they're nice enough to start asking you questions about the graph, and then you can come to some sort of consensus on the meaning. Or it's worse, right? It's your boss, and he goes out and decides to spend $25 million on something here. So my plot said the exact opposite of that. So, right, I try never to use 3D plots if I don't have to. They're certainly very pretty. Like astrophysics people love a 3D plot, right? I mean, because the universe is kind of a neat thing to look at, right? And it's almost instantly, right? You throw this up and go, well, so this is however many light years, and using distances and colors, and I got none of that, right? I got like energy lines. Nobody really cares about that. But I mean, there are things that I can do to make 3D graphs. But if I do that, then I, especially Russians, they ask a lot of questions. And, I And you can run yourself down a rabbit hole. And, so you have to sort of know your audience and be a little bit careful about what is your plot. Like I say, for me, I just never use it. I just never do. Yeah. Good. Just stretching. All right. All right. All right. And then give me just a minute, please. I'm sorry.
Another one of the libraries that's mentioned at the end of the book, Bokeh.
Yes.
Bokeh gives you a lot of really advanced plotting capabilities, really complex visualizations. The website that has all the examples has some really, really cool ones. One of the cool things about Bokeh is it creates an interactive plot. So, yeah, and so if you're serving it online, someone can go in and select a subset of the data, and then it will redraw the graph based off of the subset of data that you've selected. You can do that with Bokeh too.
And you don't need like JS capability, JavaScript.
It actually runs JavaScript.
Yeah, but
Yeah.
like you don't need to be like a D3JS kind of.
No, it does all of that for you.
I was looking at comparing Bokeh and Plotly, and Bokeh seems to be slightly more popular, but it was only recently, November, something like that, that Plotly became open source.
Mm-hmm.
So I figured that, but Plotly was giving it a Bokeh and running for its money. So if they were to do new surveys now that Plotly is free, I figured that might change. I think Plotly does the D3 stuff and
Yeah.
Bokeh. So
Bokeh does interface with D3, I'm pretty sure.
Is that the Bokeh?
Bokeh.
Okay. I just went.
That's what he told me.
Yeah. I don't know if it. Yeah, I don't know if it. I didn't know if it was Bokeh or.
Photography,
Like,
when
yeah.
something gets blurred out, that's okay.
Oh, okay. Gotcha. All right. I'm sorry about that. Are you ready to move on? Okay. Now, so this is just a straight scatter plot, and again, it's these are all hand-entered lists, but right. The nice thing is you can use what this means is right. So you can plot, and here's another way to get multiple dimensions on one plot. And it's a relatively simple thing to do. So you have two sets of numbers and then labels for the points. So you plot them as a scatter plot and then add the labels to the plots. But again, right, this is pretty format intensive, right? You got an add and offset. So this is all, for being a programming language, this is all done rather manually, right? And again, add the title, add the label. This time he does put an X label, a Y label, and the show. So that should, yeah. All right. Daily minutes, numbers of friends. Daily minutes spent on the site. All right. And here's another misleading, a nice way to, or a relatively easy way to mislead yourself, right? So in this example, if I remember correctly, let me check the next one. He's showing the variance between two exam sets of exam scores for a course. So in the first plot, so what's plotted is on the x-axis the test 1 grades, and on the y-axis the test 2 grades. So, and when you look at the plot, you think, well, so there's a huge variance in the test 1 scores, right? Just by looking at the points, right? If you don't look at the axes and go through the, mental manipulation, then you're immediately drawn to the fact that in the horizontal direction, which is related to your x-axis. So the test 1 grades have a big variance. But the problem here is that the axes don't cover the same range. So you see the x goes from 75 to 100, and the y goes from 50 to 110. Right, so when you do normalize the axes, right, what you end up finding out is, well, heck, there's a lot of variance in the y direction. So it's actually the test 2 scores that vary quite a bit. And the test 1 scores are in a relatively narrow range between 80 and 100. The test 1 scores are in a relatively narrow range. Looking at the x-axis, right, they're between 80 and 100. The test 2 scores vary anywhere from 60 all the way up to 100. So. Right. Yeah. And I thought the same thing, right? Ideally, what you would do is you'd specify the distance, right? You'd specify the x range and the y range, and you would force the plots to plot over. I mean, you could certainly do minimum score, but you might want to, for whatever purpose, right, start at, well, I know an F starts at 50, so I'll plot from 50 to 100. Plot both axes from 50 to 100. But yeah, you're right. They're comparable, but they do skew the look of the scatter plot, but not nearly as bad. Not nearly as badly as the previous. Yeah. So yeah, if you had the same ranges on the axis, right, that you would sort of just squash the y, right? You'd still see there'd be more variance, or you would see that there's more variance on test 2, but it wouldn't look as drastic as it does, right? So again, right, there are real easy ways to fool yourself when you're plotting data. I think I tried to do a bokeh thing and it didn't work out for me. Or did he do it? Maybe he did it. And these are all just imports anyway, right? Yeah. Yeah, there's nothing there. I don't know. I do use it in the next one. But I thought this was kind of cool. So here's a. Was this in the book? Okay. So bokeh will allow you to make interactive plots that's about as much as I know about it. What I mean by that is I think I heard you say JavaScript and some other stuff. I know you have to have the imports right? But the plotting commands work roughly the same. But you get these handy tools, right? So it creates an HTML page. Is that right? Yeah. Yeah. Creates an HTML page, and then you can link that page in your notebook if you so desire. But you can do things like move the graph around, right? You can zoom in, zoom out, return to my original view. If I wanted to, I haven't actually tried this, so I don't know that you get any of the data when you do save. I don't know if you just get a JPEG. I guess I can try this and see what happens. Oh, okay, so I'll get a picture. And my guess is I'll get the picture of right, if I've zoomed in, yeah, so I'll get I can save the current view if I so desire. And I think I did another one here. Okay, so all this science and markers. Oh, I added lines. Right. And then again, you can left click and hold and move the plot around. Zoom in, zoom out. So that can be handy for relatively detailed plots. And Bokeh does a really nice job of. So I would call this, right, if this was a sheet of paper, this would be a print quality graphic in my mind, right? I mean, the numbers on the axes are really easy to read. There are tick marks. There's grid for the major grid lines. There's a legend.
When you hover over, say, a green line, does it show a photo of a point? It doesn't show you.
What that point is?
Yeah.
No, yeah.
But actually, it's a large.
In Plotly?
Yeah.
Yeah,
I think it's also something you can turn on in Bokeh so that you can
Right.
get access to the data itself a little bit better.
right. And I think it will actually somewhere in Bokeh you can turn on so it will it'll give you the coordinates of your mouse over the plot, so you also get to have a better idea. So I know there's no data here, but I can have the little tooltip pop up that says, well, so you're at 1.2 or something. So I would know that that's not a data, not a data point. All right. So if I go back to okay, so that is the end of chapter 3. That's the end of the visualization and visualization examples. Now, if you've got the book, the last few pages, I think, of chapter 3, he mentions other tools. And I said a little bit about that at the beginning, right? He mentions the ported ggplot, which I don't know if anybody knows what that is off the top of their head. There's something called Seaborn, which I'm going to show with the iris data. Pandas, I think, uses Matplotlib as its sort of default plotting tool. But you can use, I think the iris data uses Pandas and Seaborn. So, I mean, you're not necessarily stuck using a particular tool. If you find a tool that has something you might find useful, then it's a matter of using what you know about Python to get that tool. If it's free, right? If you can get it using Conda, you can do that. Import what you need to import, and then read the doc to figure out how to execute plots, or better yet, right, take an example right off of the toolmaker's webpage and stick it in your notebook and let it rip and see what you get. All right, so what I'm going to do now is I'm going to switch over to the Iris notebook that I have.
Do you want to share that real quick?
Yeah. Except there's data associated with it that it reads from a directory.
Gotcha.
If you're connected, if you're online, you can actually, I think, here's the Kaggle. Here, let me see if I can do that. See what happens when I do this. This is the iris data. We get everything on here. I don't see any of the data associated with it, though.
I can get the iris data.
Yeah. All right, so I'll figure out how to share this, or how to get the link out. Because like I said, I took this off of, I'm pretty sure it was Kaggle's website, and if only because the link in the header here says Kaggle. So, and it was just a quick tutorial on how to use Pandas, Matplotlib, and Seaborn. So, make sure I've got my links set up here. So there were, let's see, 1, 2, 3, 4, 5, 3, 5. So there are 5 data files associated with the notebook. That in addition to the notebook, you'll have to download you'll have to go get the data files. And if you put them in your directory under input, so whatever your where you've got your notebook, create an input folder and then stick the data in that input folder. Everything should, all the links in your notebook should work right out of the box. All right. So one of the really neat things, again, that you can do with Pandas is, for those of you who know more about Pandas than I'll probably ever know, and cringe when I say it's Excel-like, then I apologize in advance. But you get a really, you can think sort of in terms, with Pandas, you can think sort of in terms of spreadsheets. And you can do, these Excel-like things, right, like pivot tables. You can apply functions to entire columns of data. And the functions that you apply have been optimized to work really, really quickly. So it's really kind of a handy library to use. Right, and so here you see the magic Matplotlib inline, so that we see all the plots in the notebook. And then Seaborn is the library, the plotting library, which I import as SNS. And again, here's pyplot as plot. I don't know what this does. I don't know what would happen if I called this, I don't know, PYT. Is that going to crash? Is that going to interfere with the other notebook that I have open? Do you know?
I don't know.
I don't know either. Maybe I can do that. I'll do that in a minute. Right. So so you can do this in Matplotlib as well, right? You can specify, say, up front in that header portion of your document or your notebook, what the general look and feel of your plots should be, right? So, and I can open up, I'll open up some of the plots I have for some of my data, and I've made, because I'm getting old and my eyesight's going bad, and I went straight economy with the laptop. I have to make my plots like Fisher Price Duplo font size, right? So there's things that there are parameters that you can specify in your header to get a size 18 font on your axes, for example. And in this case, right, you see more, we set the background to white and told to use color codes. And then I set a variable iris. This is a command from Pandas to read a CSV file and store it in this variable iris. And then you can use Pandas functions for, in this case I use iris.head, and it'll give me the first five rows and all of the columns of whatever data I want to, I've told Iris to acquire. So you get row numbers and you get column headers if they're in your file. You can also, those are things you can also specify when you're importing the CSV file, or if you're creating a data frame from scratch. These don't have to be, Your row numbers don't have to even be numbers. They can be dates and times. They can be Boolean values. They can be anything you want to specify. Right. So the iris.csv contains data. I have an ID column, sepal length, sepal width, petal length, and petal width, and then the species label for each of the sepals and petals. So you can do something statisticians like to do really quickly with pandas, right? I can take iris and I can refer to the column header. Instead of calling out a row, I can say, well, I know I have a column named species, so give me all of the value counts for whatever I've got in the species column, right? So, and did I hit shift? I don't know if I entered this. We'll find out. Yeah, I guess I did that one once. Let's do this one. Okay. Now, just to give you an idea how fast this is, right, there it was. Done and done, right? Now, there are only, I think, maybe 150, maybe 200, but it's a count, right? It's counting each instance of whatever's in that column, keeping track of it, and then it prints it out in pretty nice format here for you to review. And then again, we're using Matplotlib, we're using PyPlot, so you can Pandas again uses Matplotlib as the default plot library, so you can use all with whatever Pandas object you have. You can make Matplotlib calls on that object. So here we're going to do a scatter plot. And this time I made sure that if they weren't, then I made sure the axes were labeled, right? So what I get is a scatter plot of sepal length against sepal width. Now, neat things you can use all the usual kinds of things in here that you, right? So I added a line break, and so now my x-axis, the centimeters appears below sepal length, right? Nothing too extremely interesting there. Now, here's a neat seaborn plot. So this is the same plot, however, in a much prettier fashion. Right. So here's a density plot, right? Now, if you know what the colors mean, that's kind of a handy thing to have. I see here we don't have we've got labels, but we don't have a legend. So I don't know if darker means bigger or darker means nothing, 0. I mean, looking at the scatter plot, I'm going to say the darker means that the numbers are larger, right? And then you can kind of sort of see from the distributions that are plotted, right? So along the top, you've got the distribution of sepal length and then sepal width here along the y, right? So, and you can make these, since there isn't much data, it's probably a better thing for you to plot bars and not lines. You can turn these into bars. I don't quite recall how just yet, but I know that that's something that's not a, well, so what this, they call it a joint plot. What I would call it is either a density plot or a contour plot, right? And it's to give you the purpose is to give you a feel for how the sepal width and sepal length are clustered. So, right, the majority of my sepal widths and lengths occur in this in the black region or the darker region. I think that's black here, right? And that's for, we didn't bother to differentiate varieties. So this is just all types of iris in general, right? So for the 3 types, and for those of you who know Latin, I apologize. Setosa, Virginica, and Versicolor, right? We didn't bother to differentiate between any of the 3 of those. But the majority of sepal lengths and widths appear in the green, although there is some separation, right? You see the dark region here, but there's also another dark region here. So what that would tell you is that maybe the variety is important, right? Does that make sense? Yeah. Okay. sure you understand what he's talking